Hi, so in this video I'm going to discuss some basic questions on continuous random variables. So the first question that we have is fx is equal to y naught into 2 minus x with x having limits 0 and 2. In this question we have to find mean, variance, mean deviation and beta 1 and beta 2. First of all, let me write the formulas of beta 1 and beta 2. So beta 1 is, let's just see the formula of beta 1 and beta 2. So beta 1 is and beta 2 is right. So we know that this is the rth moment about origin, right? So mu 3 2 is the rth moment. This is the third moment. This will be the third moment, and the square of this will be mu 3 whole square, and mu 2 will be the rth moment with respect to the mean. Wait, this is the third moment with respect to the mean, second moment, and the square of this is the second moment with respect to the mean. Again, mu 4 is the fourth moment with respect to the mean, and this is the second moment with respect to the mean, and the whole square of that. This is the rth moment with respect to the origin. So when we have have a dash here, we say that it is the, and r down, we say that the this is the rth moment with respect to the origin. So now we have all of the formulas, and we need to find mean deviation. So mean deviation is finding x minus mu, the mod of x minus mu. Why mod? Because if we don't put a mod here, x minus mu, the summation of x minus mu will ultimately give us 0. Deviations with respect to the mean, the sum of deviations with respect to mean are equal to 0. Let's go to our third slide. So let's just start the question. First of all, we don't know what is y naught. We need to find y naught. So for finding y naught, we have a property that integrating the PDF with the limits given to us gives us the total as 1. So the probability is 1 of this event happening over both the limits, 0 and 2, over the lower limit and the upper limit. So our PDF is y naught into y naught 2 minus x wait a minute. So let's just find the value of y naught. This is equal to 1. Now y naught will go outside, 0 to 2, 2 minus x, wait, I should have put dx here. Dx is equal to 1. So now integrating this will give me y naught 2x, again dx 2x minus x square by 2, 0 to 2, y naught 4 minus 2, 4 minus 2 will give me, and then 0 equal to 1. So this is, wait a minute, 2x minus x square by 2. I've written something wrong. There should be another x here. There should have been another x here. So let me just change this. This has another x here. Another x. So this will change. This will become 2x square by 2, and this will become x cube by, because this is x square, x cube by 3. So the property of integration here that I am using is x1 dx is equal to xn plus 1, this is x, n plus 1 upon n plus 1. We have limits here, so I won't be putting in c, constant of integration. So 2 and 2 gets cancelled. I will be having 4 here, and then the whole cube of 2, this is 8 minus 8 by 3, 4 minus 8 by 3, this is 8 by 3, this is 8 by 3 minus 0 is equal to 1. So 12 minus 8 is 4, 4 by 3, 4 by 3 y naught is equal to 1. This implies y naught is equal to 3 by 4. Let me just insert another slide, new slide. Yes, so our PDF will become, PDF is fx is equal to 3 by 4 x 2 minus x. This is our PDF. Now we need to find variance. So variance is variance is ex square minus ex whole square. But what is ex? Ex is mu 1, the first moment with respect to the origin is ex. Ex square is the second moment with respect to the origin, because what we are finding here is ex minus 0 whole square. This is ex square, right? This square is not, this square is here. Wait, let me just put in another bracket. This bracket, can just write this clearly. Let me just write this clearly so that you can understand. So this is e, put in a bracket, x minus 0 whole square. Second moment with respect to the origin gives me ex square. Now the dash tells me that this moment is with respect to the origin. What is this? This is mu 2, and this is with respect to the mean. That's why I'm not writing anything here, right? This is with respect to the mean. The second moment with respect to the mean is variance. So mu2 dash will be x square fx dx 0 to 2. Let me just find this first. Can I do some of the steps here? So 3 by 4 I can take out. 3 by 4. Just use my eraser. Zero to 2. Now multiplying this x cube, 2x cube, x cube, 2x cube minus, I have x square here and I also had 1x earlier, so this becomes minus x to the power 4. So this will be ultimately, now I'll use this, two x 4 to the power divided by 4 minus x to the power 5 by 5. I'll use this expression and just put in the limits. So this was 3 by 4 again. I'm finding e, this is ex square. This is the second moment with respect to the origin. E x square. This is not sigma. Ex square. Okay. Fine. So now I'll just put in the limits. 3 by 4, and this was 2 and 4, so this will get cancelled. X to the power 4 by 2 minus x to the power 5. I had 2 here and I had 4 here. I just cancelled it. 5 upon 5, 0 to 2. This will give me 3 by 4, 16 by 2 minus 32 by 5. Minus 0. So this becomes 3 by 4, 8 minus 32 by 5. This becomes 3 by 4 into 8. 5 8s are 40. 40 minus 32, 8. 8 upon 5. This goes. This gives me 6 upon 5. Now this is 6 upon 5. Why is it greater than 1? Because this is the expected value, not the probability. Expected value can always be greater than 1, but probability can never be greater than 1. So this is 6 by 5, and this is very much possible. So now I need to find mu 1 with respect to the origin, which is ex minus 0 to the power 1. So let's just find this. X into into x into 2 minus x dx. Was this our PDF? Yes. So this will become x square, see, x square into 2, 2x square. When I integrate this, this will become 2x cube upon 3. So 2x cube upon 3 minus, this is x square, this is x cube minus x to the power 4 upon 4 minus x to the power 4 upon 4, and 0 to 2 multiplied by 3 by 4. So this will become 3 by 4. Now 2. So this will become 2 to the power 4, 2x cube. So 8 into 2, 16. 16 upon 3. 16 upon 3 minus 2 to the power 4 is 16 again. 16 upon 4 minus 0. This will give me, this is actually 4. 4 3s are 12. minus 4. This will become 4 upon 3. Can I cancel this? This has become 1. Ex, or the first moment with respect to the origin, is 1. Now our variance will be, what was my earlier value, 6 by 5. So mu, again mu 2, the second moment with respect to the origin minus the first moment with respect to the origin will give me the variance, which is ex square minus ex whole square, and this is equal to the whole square of the first moment with respect to the mean, which will give me 6 by 5 minus this whole square of 1, which is 1. So 6 by 5 minus 1, which is 5 by 5. This will give me 1 by 5. Okay, this is my variance. Let me just check my answer. This is example 5.11 from SC Gupta, Mathematical Statistics. Just check my answer. Right, so the variance is 1 by 5. Now what do we need to find? Should we find beta 1 and beta 2 first, or mean deviation? Let's just work with mean deviation first. Mean deviation, which is x minus mu mod fx dx 0 to 2. Now my mean mu is, this is ex, and this is equal to 1. Right. So now I need to find this x minus mu. So if I write the expression for this, this will be 0 to 2 x minus mu, the mod of x minus mu, x minus 1. This was our mean, fx dx. Our fx was, I'll just take out 3 by 4, or let me just write it here once, x into 2 minus x dx. This is my formula of this is my expression for mean deviation. Just put on an arrow. Okay. I need to put in another slide, 2-3 slides. I'm just writing MD for mean deviation. Yes, so our expression was 0 to 2 x minus 1, 3 by 4 comes out, x minus 1, yes, fx dx. So I will be having x into 2 minus x dx. Now this is x minus 1, this is x minus 1, and I have limit 0 to 2, and this is the mod of x minus 1. We know that this function will change its signs, so let me just ignore 3 by 4 for now and evaluate this expression. X minus 1, 0 to 2, I am just writing this as, okay, let me just write this also. Yes, so now this expression will be evaluated on two different parts, because x minus 1 mod is positive, x is this expression x minus 1 mod is negative when x lies between 0 and 1, and this expression becomes positive when x lies between 1 and 2, right? So I need to form two different limits, 0 to 1, where this becomes, see, now I can write this as minus x minus 1, or I can write this as 1 minus x. I'll be writing 1 minus x. 1 minus x, 0 to 1, fx dx. This remains same. This doesn't affect this. Mod mein, only this expression is in mod. So this doesn't affect this. X minus 2x. X minus 2x. I'm ignoring the 3 by 4 here. I'll be writing it at the end, because the whole expression is being multiplied by 3 by 4. I've taken it out common. So x into 2 minus x dx plus, now this expression will remain same, x minus 1, because there is no negative sign, this is just positive. So x minus 1, 0 to 2, no wait, let me just write this on a new page, on a new slide. I'm just erasing all of this. Right, so I'm just erasing all of this. Right, so I'll be just using a different slide, or I'll be writing this here. So this becomes 0 to 1, 1 minus x, x into 2 minus x dx plus 1 to 2, x minus 1, x 2 minus x dx. Okay, so now I'll move on to the next slide. Multiplied by 3 by 4 if you want. I can write this again here, 3 by 4, and I'll put in a bracket. See, I'm not used to writing on a pad, on a writing pad. That's why my handwriting is not clear, but you know, it will improve in some time. Now I'll be evaluating this expression, 3 by 4. 1 minus x into 2x minus x square, 0 to 1 dx plus dx. This is 1 to 2. Right, so this becomes 2x calculations part is very tiring. Two x minus 2x square minus x square plus x cube. Now plus 1 to 2, 2x square minus x cube minus 2x plus x square dx. 0 to 1, so can I write this as 2x square by 2 minus 2x cube by 3 minus x cube by 3 plus x4 by 4, 0 to 1, plus 2x cube by 3 minus x4 by 4 minus 2x square by 2 plus x cube by 3, 1 to 2. This becomes 1 minus 2 by 3 minus 1 by 3 plus 1 by 4 minus 0. 3 by 4, and here also I need to multiply the whole expression by 3 by 4. I'll be doing it at the end. So this is this was 1. So this is 2. This becomes 16 by 3 minus 16 by 4 minus 8 by 2 plus 8 by 3 minus 2 by 3 plus 1 by 4 plus 1, 2 and 2 gets cancelled, and minus 1 by 3. This is my expression. So I need to insert another slide. Wait a little bit. We just insert new slide. Right. So this expression will be, this is 2 by 3, this is 2 by 3, this expression is 1 minus 1 by 3 is 2 by 3, 2 by 3 and 2 by 3 goes away, plus 1 by 4, this becomes 1 by 4, this becomes 1 by 4, plus, now come back to this expression, 16 by 3 plus 8 by 3, 24 by 3, 24 by 3 minus 2, 22 by 3, 22 by 3 minus 1, 21 by 3, 21 by 3 becomes 7. Yes, so I have 7 here, 7, and 16 by minus 16 by 4, this is 4, this is 4, this is 4, so, and this is also 4, so this is 8, 4 and 4, 8, 8 and 1 minus 7, minus 4 and minus 4 minus 8 plus 1 minus 7, minus 7, and I haven't taken into account this 1 by 4, I don't think so. So this also becomes 1 by 4. So I have 7 minus 7 plus 1 by 4. Plus 1 by 4. Right. So this becomes 2 by 4 or half. Shall I first check my... no. This becomes 16 by 3, 16 by 3 plus 8 by 3, 24 by 3, 8, no, 16 by 3, 24, 24 by 3, 22 by 3, 21 by 3, 7, 16 by 4, 4, 4 minus 8, minus 8, minus 8, plus 1, minus 7, minus 7, 7 minus 7, oh, okay, I have 1 by 2, this should be 1 by 2, let me check my answer from the book first, this is 1 by 2, into 3 by 4, wait, I had 3 by 4, see, I made an error. So my mean deviation is finally 3 by 4 into 1 by 2, which is 3 by 8. This should come out as 3 by 8. Yes, this is 3 by 8. So we are right. This is 3 by 8. Now coming to the next question, next part. I need to find beta 1. This is the formula. The second moment, the third moment with respect to the mean and the whole square of that. When nothing is here, we say, when there is no dash here, we say that this is with respect to the mean, and when there is one dash here, we say that this is with respect to the origin. So the third moment with respect to the origin, the square of that, So we need to find mu, the third moment with respect to the origin, the whole square of that. But what is the formula for the third moment? Let me see the formula for the third moment first. The formula for the third moment is the third moment with respect to the origin minus 3 times the second moment with respect to the origin into the first moment with respect to the origin plus 2 times mu1 dash the whole cube of this. This is a very rigorous calculation. We have to do a lot of things here. So first, the third moment with respect to the origin. Third moment with respect to the origin. This implies that E, expected value of x minus 0 whole cube. So we just have to find out this ex cube, which is x cube fx dx with limit 0 and 2. Can I find this now? I need to go to a new page. So mu 3, third moment with respect to the origin, this is equal to 0 to 2 x cube fx dx, which was x into 2 minus x dx, which is 0 to 2 x to the power 4 into 2 minus x to the power 5 dx, which will give me 2x5 upon 5 minus x to the power 6 upon 6, 0 to 2. 2 by 5, 2 into 32 by 5, 2 into 32 by 5 minus 3 by 4. 3 by 4 was also a part of our PDF. I don't know why I'm ignoring it again and again. I don't know why. 32 by 5 minus into 3 by 4, again 3 by 4. 2 into 32 by 5 minus 2 to the power 6, which is 64, I guess. 64, 32 is 2 to the power, yes, 64 upon 6 minus 0 into 3 by 4. So 64 upon 5 minus 64 upon 6 into 3 by 4. Can I take 64 out common into 3 by 4? This becomes 30, the LCM of 5 and 6. And this gives me 6 minus 5. 4 into 16 is 64. Um, 48. Three tens are 16. 2 fives are 2 eights are 8 upon 5. 2 twos are 4, 2 fours are 24, 15, 3 fives, yes, 8 by 5. This is our third moment with respect to the origin. So now what all did we need to find this? The third moment with respect to the mean. We needed this, we have got this. We found this earlier, we found this also earlier, and we also found this earlier. So we can put in all of the values and find the third moment, the square of the third moment with respect to the mean. Square of the third moment with respect to the mean. So first, let me just find this. This was. Let me just write all of the values first. So So this was 1 and this was 6 by 5. So the second moment with respect to the origin is 6 by 5 and the first moment with respect to the origin, which is the mean, is 1. The third moment, wait, let me just erase this. So the second moment with respect to the origin is 6 by 5 and the first moment with respect to the origin is 1. Now the formula for the third moment with respect to the mean is, I'm just trying to remember the formulas. I don't remember the formulas. That's why I need to look them up from the book. The third moment with respect to the origin, minus, is it minus? Yes, minus 3 times mu second moment with respect to the origin into first moment with respect to the origin plus 2 times the first moment, the cube of the first moment with respect to the origin. The third moment with respect to the origin minus 3 times the second moment with respect to the origin minus into first moment with respect to the origin plus 2 times the cube of the first moment with respect to the origin. So this will give me, right, so what I'll be getting is 8 by 5 minus 3 times the second moment, where's my second moment? Yes, this was 6 by 5. Why am I going to other slides? I have written this earlier only. 2 into q. So my third moment is 8 by 5 minus 18 by 5 plus 2, which will be giving me minus 10 by 5 minus 2 plus 2, 0. I have made some error. No. Is this 0? I need to check. Yes, this is 0. Why? Because the third moment with respect to the mean is 0. So automatically this was beta 1, and the formula for beta 1 was, I need to look up the formulas from the book, I don't know, remember them. So the third moment, the whole square of the third moment with respect to the mean, right? There is no dash. If there was a dash present, we'll say that this is the third moment with respect to third moment. The third moment, we would have said that this is the third moment with respect to the origin if there was a dash present. Now the denominator contains the second moment with respect to the mean. If there was a dash present, we would have said this is the second moment with respect to the origin, but there is no dash present, so we will be saying that this is the second moment with respect to the mean, which is variance, right? What is variance? Variance is Vx is equal to Ex. Now there is no 0 in this, so second moment the power should be 0. Second moment tells us that the power will be 0, but variance is also known as the second moment with respect to the mean. So what can I write here? What should come here? Should I put in 0? Should I put in some other number? What should I put in? Mu. And what is mu? Mu, or the first moment with respect to the origin, or Ex. So variance is Ex minus Ex whole square. If you open this up, you will be getting which is mu2 or variance of x. Now this was whole cube. This is 0, so ultimately what we will be getting is 0, right? Because the numerator is 0. The denominator was 6. The denominator was. Wait, let me just check in the denominator. This might help in computing beta 2. Where is my variance? I cannot. So my variance was 1 by 5, right? So 0 upon 1 by 5 will give me 0, which is 0. So I'll be now inserting some more slides. Three slides. So mu this is yes, so my beta 1 is equal to 0, right? Now the formula for beta 2 was mu 4 upon mu 2 whole square, right? Mu 4, we need to find this. I need to see the formula for mu 4. The fourth moment with respect to the origin minus 4 times the third moment with respect to the origin into first moment with respect to the origin plus 6 times the second moment with respect to the origin multiplied with the first moment with respect to the origin to the power 2 minus 3 times the first moment with respect to the origin to the power 4. So I need to find this value. I have all the other values. Fourth moment with respect to the origin, this is right. So this will be 0 to 2 x to the power 4 into x into 2 minus x dx which is two x to the power 5 minus x to the power 6 minus x to the power 6 dx. Let me just write this whole expression again. 2x to the power 6 upon 6 minus x to the power 7 by 7 into 3 by 4. This will be 3. 2 divided by yes, 2 upon 6 is 1 by 3. So 2 to the power 6 is 64 minus 64 upon 3, and 2 to the power 7 is 128. 64 into 2, 128. Yes, so 128 upon 7 minus 0. So this will give me 3 and 3 goes away, 4, 16. Now 3 by 4 into 128 upon 7. 4 3s are 12, 4 2s are 8. This is 3 to 16 minus 6, 96 upon 7. 3 2s are 6, 3 3s are 9. Yes, 7 into 16 will be 70 plus 42, 112. 112 112 minus 96 upon 7. See, 112 minus 90, 22 minus 6 will be 16. No, wait, 112 minus 90 is why can't I do basic arithmetic? Shit, am I cooked? 16, yes, 16 upon 7. Let me just check it again. Six, 1, yes, 16. I've lost the power to do basic arithmetic. Yes, so this is 16 upon 7. The fourth moment with respect to the origin. New slide. Now the formula for the fourth moment with respect to mean was 4 times mean. Let me just check in the formula. Mu 4, yes. This is 4. We found this just now. Minus or plus or 6 times. If this comes in any exam, they should be giving this formula. This is too big to remember. My hands are all sweaty. Let me just check this. Minus 4 and 6. Yeah, minus 3. Okay, so mu 4 is, this was 16 upon 7 minus 4 times now this was 8 by 5, right? This was 8 by 5. 4 times 8 by 5. This was equal to 1, mu 1, with respect to the origin, plus 6 times. This was 6 upon 5 into 1 minus 3 into 1, 4, which is equal to minus 32 upon 5 plus 36 upon 5 minus 3. This is 4 upon 5. 4 upon 5. 16 upon 7 minus 3 minus 4 upon 5. The LCM will be 35. 3 into 35 is 90. 15, 105. 105. And 16 into 5 is 80. 50, yes, 30, 80, 80, and this is 3, this was 105, minus 4 into 7 is 28, so this will be negative. This is 105 minus 20 is minus 80 is 100 minus 80 is 20, yes, so 25 minus 25 minus 48 plus 5 minus 53 upon 35. I don't think so. I may have made some error in my calculation. 28 plus 25, 45, 8, 53. I might have made some calculation, but let's just go with this, and we'll check our answer at the end. New slide. Right, so this is equal to 50 minus 53 upon 35. Mu 4 is minus 53 upon 35. Our formula for beta 2 was mu 4 upon mu 2 square. Mu 4 upon mu 2 square. I have made some mistake. Let me just check. This is plus 4 by 5, right? 36 minus 32. This is plus 4 by 5. This is plus 28. This becomes 3 by 5. 3 by 35. I made some error. I was looking at the book for the formula and I found my error. My answer was not matching. Now it's matching. So this is 3 upon 35. Now I have found out this. What can I do? Now I need to just put in the values. Mu 4 upon mu the square of the second moment, with respect to the mean, which is the variance. This was the variance, and our variance was 1 by 5, and the square of this upon 3 upon 35. 3 upon 35, which is equal to 3 upon 35 into 25 into 25. 5 7s are 5 5s are. This is 15 upon 7. My answer is most probably correct. And my beta 1 was 0. Yes, this was correct. So this was example 5.11 from the 5th chapter, Random Variables and Distribution Functions of S.C. Gupta.